Forecast for more than 6,500 new Earth observation satellites by 2035 highlight why rapid, reusable launch capacity will determine who captures the coming manufacturing surge. This is SpaceX Daily, episode 78. This week brought updates on Starbase expansion plans in South Texas, confirmation that NASA's Dragonfly mission will ride a Falcon Heavy in 2028, and continued regulatory steps for Starlink in South Africa. Novaspace projects more than 6,500 Earth observation satellites will reach orbit by 2035, generating $155.9 billion in manufacturing revenue. Governments are driving much of the demand through expanded sovereign intelligence and surveillance programs. The forecast covers both government and commercial constellations that will require frequent, cost-effective rides to orbit. Reusable medium and heavy lift vehicles are positioned to handle the bulk of these deployments given the projected cadence. Paris-based analysts released the numbers this week after reviewing government procurement pipelines and commercial operator filings through the early 2030s. The $155.9 billion manufacturing figure reflects average satellite costs across optical, radar, and hyperspectral payloads. California startup ELV has completed spaceflight qualification of its 100-watt millimeter-wave traveling wave tube amplifier platform. The work was supported by U.S. Space Force Small Business Innovation Research funding. Qualification testing addressed the vacuum, thermal, and radiation environment of low Earth orbit. The amplifiers target high-bandwidth satellite communications links where millimeter wave frequencies enable higher data rates than traditional bands. Engineers at ELV subjected multiple flight representative units to thermal vacuum cycling and total ionizing dose radiation exposure at levels expected in sun-synchronous orbits. The 100-watt output specification was verified across the full temperature range while maintaining spectral purity required for dense frequency reuse. Arianespace has dropped previously announced performance upgrades for the Ariane 6 launch vehicle. The decision leaves the rocket at its current payload capacity without the incremental improvements once planned. European operators now face a narrower set of options for medium-heavy payloads until a next-generation vehicle arrives. The baseline 2-core configuration will therefore remain the sole operational variant for the foreseeable future. Industry sources indicate the cancelled upgrades would have added roughly 1 ton to geostationary transfer orbit performance. No public cost figure for an Ariane 6 mission has been released. Observers on r/SpaceX Lounge are examining what the planned retirement of Falcon 9 means for Vandenberg's future launch pads, noting that SLC-6 has already seen shuttle-era structures removed, yet no Starship infrastructure has been announced there. Users point out that Vandenberg could surpass Cape Canaveral in total SpaceX launches this year, and worry the site may go quiet once Falcon operations wind down. A separate post revisits the logistics of recovering Ship 40, with contributors debating the value of returning the vehicle to Texas versus leaving it on a heavy lift vessel. Worth keeping an eye on is Europe's decision to cancel Ariane 6 upgrades, which removes near-term competition on certain medium payload missions, but also signals slower European launch cadence overall. Without the improvements, Arianespace will rely on the baseline vehicle configuration for the foreseeable future. The move could shift some government payloads toward U.S. providers, yet it simultaneously underscores that European sovereign launch capability remains constrained until a successor system is fielded. Resolution depends on whether a follow-on European rocket program secures funding and accelerates development. On the AI front, no new source developments appeared today on the SpaceX xAI Grok cursor compute thread. The live threads to watch remain orbital data center concepts, direct-to-cell backhaul, Colossus-scale cluster expansion, and Grok distribution inside developer tools. In the engineering deep dive this week, millimeter wave traveling wave tube amplifiers solve a fundamental link budget problem in satellite communications. At these frequencies, the available spectrum is far wider than at S or Ku band, so the same aperture can carry many times more bits per second, yet free space path loss rises sharply and atmospheric absorption becomes material. A 100-watt TWT must therefore deliver that power while surviving the vacuum, thermal cycling, and radiation environment without excessive mass or heat rejection. Qualification testing therefore focuses on cathode life, helix thermal management, and collector efficiency, because every watt not converted to RF output must be radiated away. Once qualified, the amplifier enables tighter beams and higher order modulation on small satellites, directly lowering the cost per delivered bit and allowing denser constellations to share spectrum without mutual interference. The same physics that makes millimeter wave attractive also explains why optical links are being pursued in parallel. Both approaches trade aperture size and pointing precision against raw bandwidth, but the TWT path avoids the cloud and daylight constraints that still limit laser terminals. In first principles terms, the raw material cost of the helix, collector, and cathode assembly is only a few $100s, yet the finished, space-qualified unit commands orders of magnitude more because of the precision machining, vacuum brazing, and multi-month test campaign required to guarantee 20-year reliability. That gap is the classic idiot index for RF hardware. Each successful qualification run collapses the index by proving the design can be reproduced at lower cost on the next batch. ELV's SBIR-funded path therefore represents a deliberate attempt to move the index downward for the entire industry rather than for a single mission. The net result is a practical middle ground that lets operators increase throughput without waiting for fully optical networks to mature. For constellations already sized around thousands of satellites, even a 20% improvement in bits per watt at the amplifier stage translates into measurable reductions in required solar array area and battery mass. Those mass savings compound across every launch, directly affecting how many additional Earth observation payloads can ride on the same reusable booster. Over the 2026 to 2035 window projected by Novaspace, the cumulative effect of such incremental hardware gains will determine whether the $155.9 billion manufacturing forecast can be realized within existing launch economics or whether new capacity constraints appear. Turning briefly to the markets, the stock moved higher on the session. Before we go, reusable launch providers will be watching how the projected Earth observation surge translates into firm mission manifests over the next 2 years. That's the day at SpaceX. That's a wrap. SPCX is trading at $136.97, up 2.8%. If you're new here, subscribe and this briefing finds you every day. I'm Patrick in Vancouver. Thanks for being here, and I'll see you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Shorts Time, your daily deep dive into everything Tesla. Find every show free at naranetwork.com. The age of AI puts real builders on the phone with an AI host. Apply at naranetwork.com. Age of AI apply. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.